All right, so let's go ahead and go over the endocrine system. The endocrine system being our glandular system, and we're going to, if you remember in the nervous system where we did that little flow chart study guide kind of thing, we'll be doing something very similar, right? Because we can essentially just write out the glands and then do a little flow chart of what hormones that the gland in itself produces. So let's go ahead and crack into the system. Just a few preliminary things before we get to the functions of the system, mostly because I wrote these questions and slides out to go in line with your book. But what exactly is the difference between neurotransmitters and hormones? Well, they are similar, we'll say this first, in the sense that they are molecular structures uh, that chemically alter and change and cause things to happen in the body. It's just that neurotransmitters are specifically produced by, well, through the nervous system and used by the nervous system. Hormones are just the general chemical messengers of the body produced by the various glands that we're about to see. Now, they're both chemical messengers, right? They're both little molecular chemical structures, again, like we said, that change things in the body. It's just one's produced by one system over the other. Now, when it comes to the glands that we're going to be looking at, there's two different types of glands. We have endocrine glands versus exocrine glands, where you're like, oh, well, this is the endocrine system, so where does the other one come into? Well, it's all based off of where they're releasing their hormones. So endocrine glands secrete their hormones directly into the bloodstream, which then circulates, or the interstitial fluids and spaces of the body, which then circulates through the entire body to get to where they're trying to go. Exocrine glands secrete their hormones directly into ducts that will enter into certain structures, or they will secrete themselves into the cavities of organs. So, for instance, like enzymes and other various things secreted within the digestive tract to propel digestion and so on and so forth. Right, because we're going to use those immediately right there in that particular area, and we'll see a good mix of these throughout the unfolding of the lectures. So now we're getting into the actual functions of the endocrine system, which we can simply say that the functions of the endocrine system is to produce hormones. And then the rest of the functions just line up with, well, what those hormones are basically doing, which lines up with these few various functions, which is to regulate metabolism, right? We're going to see quite a few various hormones that are responsible for growth and development of our bodies, uptaking nutrients and breaking down nutrients, stuff like that. So we'll also notice that there's chemical messengers, the hormones that are responsible to help and aid in stress adaptation. Now, we'll also see that there are hormones that are specifically designed to help balance the chemical compositions of the body, as well as regulate the fluid composition of the body, which is also going to in turn relate to our blood pressure, right? So we'll see how all that works. And of course, hormones, the biggest example you think of hormone wise is someone being like a teenager growing and developing. So reproductive processes and regulatory processes and those faculties will also be managed by the endocrine system. So question 4, just because it's specifically defined right there in the chapter, what are the chemical messengers that regulate the physiological activity of other cells? Well, they're hormones. So when a hormone is released into the bloodstream from an endocrine gland, we want to make sure that it gets to the right place, or it only targets the appropriate cells and receptors of the body that need to, right? We don't want just every single cell and everything just in our body, sort of, for lack of a better explanation, getting high on every other drug out there. So we have what's called a target cell, and we have specific things that allow cells to be targeted, and they're on the cell in and of itself. So a target cell is, of course, the cell in which we are targeting, and the target cell contains receptor sites that allow this chemical bond to bind to it to then cause the changes into that structure. We actually saw an example of this in the nervous system and the muscular system when we looked at the neuromuscular junction. We did briefly see that in the folded sections of the sarcolemma of a muscle, there were receptor sites for acetylcholine to bind to, which then would cause, the muscular contraction for sake of longer explanation. So to make sure that, we make sure we target the right cell, we have receptor sites that bind specifically to certain shapes and hormones. Now, we did talk about the exocrine gland functions, right? And that we're going to produce hormones, relatively right where we need them, specifically, like say we said, in the hollow space of an organ. So these hormones that are produced locally are called prostaglandins. So we have them working, usually on that corner, right where they're usually centrally located. They don't have to go very far, straight to the corner, those good old prostaglandins. So prostaglandins are called local hormones. Now, what dictates the use or the release or the need to produce hormones in our body? Well, there's lots of what we call loops and feedback systems, but one of the most common is a negative feedback loop or a negative feedback system. So essentially, when things move into the opposite or negative direction, we encounter a negative feedback, and our body attempts to regulate and balance that, typically with a hormonal response or a neural response, to then bring levels back up to where they need to be. So as you can see in the little example picture, right, this person gets cold, so they start to shiver, brings their temperature back up. If they get hot, we start to sweat, and it brings our temperature back down. Other examples would be, say, eating a cupcake, right? So we'd eat a cupcake, our blood sugar spikes, our pancreas is going to release insulin to then deregulate the blood sugar content of the body. And then vice versa, right? If we're low blood sugar, we use glucagon, whatever, good stuff. So hormonal regulation is the process of those negative feedback loops kind of going into play, which is that our glands and hormones are going to regulate the function of other glands. Now, a gland that produces a hormone that reaches out to another gland to then tell that gland to start working is called a tropic hormone. So if you think about, well, this hormone is produced by one gland and it's going to another gland on a vacation, it's going to the tropics. Now, this is important when we actually start looking at the various different hormones, because you'll notice that some hormones have tropin or tropic in their name, and that's going to indicate that they're going to another gland to then, cause some functionality of that other gland, especially when we look at one of our major glands here, the hypothalamus. Neuroregulation, another way in which we would, cause the, release of hormones and regulating systems in the body. Well, neuroregulation, very similar to hormonal regulation, is our nervous system regulating hormone release because of, neural sensors. So a few examples of this perfect, it's actually in the picture. But we have baroreceptors that measure the pressure or stretch in the arteries, especially in the aorta, that detect essentially and monitor the blood pressure in our system. And so if that blood pressure is high and our nervous system, picks up on that, it will have the heart and the kidneys release certain hormones that we'll take a look at here in a bit to lower blood pressure. by usually urinating and releasing fluids from the system. Other ways would be like the sympathetic response, activating the adrenal glands to then release hormones and needs of stress adaptation. And let's see another example. That's all I really got for right now. And then we'll kind of see how the the hypothalamus and the pituitary gland have a very intimate relationship, which is technically a form of neuroregulation. So, cracking into our first hormone, first gland, which is actually technically still an endocrine, a nervous system structure. We're looking at the hypothalamus. So, the hypothalamus produces stimulatory and inhibitory glands, hormones. So first, let's define stimulatory versus inhibitory. If a gland is stimulatory, that means it causes another gland to produce or do something. If it's inhibitory, well, it inhibits that function. So it stops that function. So let's take a look first at our little flow chart here and write out the hypothalamus on our little chart. And then we can do another further flow chart breakdown of, we have excitatory and inhibitory. I might need more board for this, but we'll see if it works. So let's go back to our slide here. And take a look at which ones we're dealing with. So we have quite a few. So we can arguably say that the hypothalamus is actually the master gland, even though technically most texts will list the pituitary gland as the master gland, as we'll see why. But the hypothalamus is technically pulling the chain of the pituitary gland. Because the bulk of the hormones produced by the hypothalamus are going to the pituitary gland to tell the pituitary gland to tell everything else to do things, basically. So I guess we could call the if the pituitary gland is the master gland, right, the head of the household, we'll say, the hypothalamus is, the real head of the household, the person behind the scenes who really calls the shots, the mistress, the wife gland. So let's take a look at some of these hormones here. We can just use that chart, nice and easy. So we have thyrotropin releasing hormone. So in this case, releasing hormone is going to be a stimulatory hormone because it's going to tell the pituitary gland to release this particular hormone. So I'm going to just use abbreviations. So we got the thyrotropin releasing hormone. So in this particular case, all of these hormones are going to tell the pituitary gland to release a hormone. In this particular instance, thyrotropin releasing hormone is going to tell the pituitary gland to release thyrotropin hormone. So we also have oxytocin, which is, I think, actually, OXTC is the actual technical acronym, I think. So oxytocin, we kind of talk about that with, birth and child care. Typically oxytocin is what usually is used to induce labor, and then it's usually produced in high quantities during pregnancy and childbirth, right? And it's also, we call it the bonding chemical as well. When two people connect and I guess love each other, I guess you could say, oxytocin is produced in higher quantities when being around someone that you care about. We have gonadotropin releasing hormone. Well, if you could think about it, gonadotropin, well, obviously a stimulating hormone because it's to release. Gonadotropin, well, gonads, genitals, right? So this is going to tell the pituitary gland to release various, you know, reproductive-based hormones. Growth hormone releasing hormone. Well, as simple as that, it's going to tell the pituitary to release growth hormone. Vasopressin, that's for the kidneys. I'm not going to list it as it's a very specific one. And same with the somatostatin, which is, specifically for, muscle development and bone development. But whatever. We're going to look at corticotropin releasing hormone. So that's our first instance of seeing tropin or tropic, right? So that means that this is going to specifically this one is going to tell the pituitary to release corticotropin, which is then going to go to another gland, specifically the adrenal glands, for the corticosteroids. And then so we do have to have a couple brake pedals, and it's not listed actually on the, because that's only the releasing factors, the stimulatory hormones. So our inhibitory hormones include growth hormone inhibiting hormone, which obviously, like, we don't want to produce too much growth hormone, right? Because then we would be gigantic, which I guess wouldn't be too bad in some cases, like that guy over there. But we have to have that brake pedal. And then we have prolactin inhibiting hormone to decrease the production of various reproductive hormones. All right. So now we're taking a look at the pituitary gland, which is the bulk of this lecture, to be honest. So typically I say when it comes to hormones and learning this system, it's better to learn all of the other glands and the 1 to 2, maybe 3 hormones that those produce. And then when in doubt, anything else that you don't know or studied from other glands, just answered anterior pituitary. Why? Because the anterior pituitary is responsible for releasing far too many hormones, as you're going to see here in a moment. So just statistic average, if you answer anterior pituitary glands, you're probably going to be right, at least statistically average. So first up, the pituitary gland is located, as we learned in the nervous system lecture, is located in the diencephalon of the brain, the little hollow center of the brain. But it specifically sits in what's called the sella turcica of the sphenoid bone, which breaks down to Turkish saddle, and it's literally like the master seat of the house, because the pituitary gland is literally going to control everything in your body. Almost, it kind of reminds me of I'm probably aging myself here, that Men in Black movie, where they open up that guy's face and it's a little alien sitting inside there in that little seat. Well, that's your pituitary gland if you think about it, right? So that's where the pituitary gland is. Now let's take a look at the actual structures and hormones produced by the pituitary gland. So again, over here, and I'll zoom in later so we don't have to come out of the slide, we're going to write down pituitary gland. And as we see here, we have an anterior lobe. So obviously anterior lobe is going to imply the existence of other lobes. So we're going to factor tree that out, and we're going to do anterior lobe. And there is a middle lobe, but typically it's very insignificant for our purposes. So we kind of just lump sum the middle lobe into the posterior lobe. So we're going to put posterior lobe as well. So these various lobes, the anterior and posterior, go by specific names. So the anterior lobe is known as the adenohypophysis. So we can think like, I don't know, sometimes since the anterior lobe is the main lobe calling the shots, he's like the boss. And I don't know, I think like a mob boss, like, hey, Dino! Hypothesis. I don't know. That was my example. Try to think of a better one, but now specifically, this adenohypophysis is connected to the hypothalamus, where it's serving those exocrine functions. The hypothalamus secretes its hormones to the anterior lobe through essentially a straw, a slender stalk as it's called, the infundibulum. So we're producing these hormones, they slide down a little chute into the anterior lobe to then release their hormones. Now, the posterior lobe is called the neurohypophysis, which should be a little bit easier since we should know that the neurohypophysis is connected to the hypothalamus by means of a neural connection. So this way, now so we can see right here between the hypothalamus and pituitary, two types of regulatory systems. We have hormonal regulation, right, through the exocrine functions, and we have neural regulation through, well, the various nerve endings that stimulate the neurohypophysis. So let's take a look at the specific hormones produced by each lobe or each side. So as we said, and I mean, just look at that big, long list of hormones for the anterior pituitary gland, and then only 2 in the posterior side as well. So let's just go ahead and write all those out. So we have adrenocorticotropic hormone. We have the thyroid stimulating hormone. We have growth hormone. We have the follicle stimulating hormone. We have, I think, prolactin, and then what's the luteinizing it, prolactin, and melanocyte stimulating. Luteinizing hormone, prolactin hormone, and melanocyte stimulating hormone. And then in our posterior lobe, we just have antidiuretic, ADH, and oxytocin. All right, so lots of hormones in that anterior lobe. And now you might see why I say, when in doubt, just answer anterior pituitary lobe, adenohypophysis. So adrenocorticotropic hormone, well, adrenal, corticosteroids, tropic means a hormone that is going to another gland to then cause its functions. So adrenocorticotropic hormone goes to the adrenal glands to then, stimulate the various parts of the adrenal gland, and we'll take a look at the hormones produced by that as well. So, cool. We have growth hormone. So growth hormone is used by various, structures throughout the body to, regulate growth and development, muscle-wise, bone-wise, all those good things. Thyroid stimulating hormone is going to the actual thyroid, which is then going to, cause the thyroid to produce whatever hormones that it does, and we'll take a look at those. Follicle stimulating hormone, luteinizing hormone, and prolactin are essentially our we can loosely say reproductive-ish function glands there, right? So like follicle stimulating hormone, helps with like the hairs and stuff. It helps with, gametes and things like that. Luteinizing hormone helps with the regulation of the actual sexual glands, the testicles and ovaries, so on and so forth. Prolactin, right, helps with, the breast lactation, all that good stuff. So, loosely, we could just summarize all three of those into sexual-based hormones. And then melanocyte stimulating hormone, well, that helps to stimulate the activity of melanocytes, which we'll see when we get to the integumentary system. The melanocytes are the cells in our skin responsible for our skin pigment and synthesization of UV light from the sun. So that helps with that as well. So then we see in the posterior lobe anti-diuretic hormone, our first form of blood pressure reduction hormone. So anti means to not do, diuretic hormone. So antidiuretics cause us to retain water by not urinating. So if we take out anti out of that equation, if we had a diuretic is a medication that makes us pee. So this hormone would be released if we needed to increase blood pressure or retain water in our system if we were potentially dehydrated. And then oxytocin, we already kind of explained what oxytocin was. So to be honest, this slide right here, this gland right here is the lecture. And then all we need to do is just make a list of other glands and the small amount of hormones that they produce. So let's get into those glands. First up is the pineal gland, and its primary hormone is melatonin. So melatonin is a very important hormone. Many of you probably supplement or take this, and you usually take it to relax and sleep, because melatonin helps to regulate the circadian rhythms of our body, such as the sleep and wake cycle, as well as other various relaxations. Now, melatonin is produced by the pineal gland when we don't have light exposure to our eyes. So this is why they say, roughly before, like an hour or so before bed, cut off all the lights, cut off the phone use, cut off the TV use, right? So that way your body can naturally be, led into producing melatonin, because if we have light, artificial light, it sort of messes with our body. Technically our bodies have developed over a long, long period of time. And, it's only been so few in life that we've had bright ass lights. Sorry, might need to censor that one, in our world, right? So we never had fluorescent lights and bedside lights as bright as they are aside from the recent history. So, having these lights off can really help with, regulating these rhythms, especially with the pineal gland. So looking at our thyroid gland actually produces quite a few different hormones, but we're going to look at a few specific ones. So T3 and T4, as well as calcitonin. Now, it's the calcitonin we're going to pay a little bit more attention to, specifically because we've already seen in the skeletal system lecture a particular activity called osteoblastic activity, produced by osteoblasts. These osteoblasts, as we remember, are the cells of the bones of the skeletal system that build new functional bone. So calcitonin stimulates osteoblastic activity, which then essentially tells the body to pull calcium out of the bloodstream and place it into the bones. So, and do we have the parathyroids, which are, I should have a picture here. They're actually, so if we looked at the thyroid gland, you see the thyroid gland kind of looks like this butterfly wing looking thing. So behind this thyroid, on the very back side, are these 4 glands, sometimes 5, 4 to 5 glands called parathyroids, because they're alongside the thyroid. And lo and behold, the parathyroids release parathyroid hormone. Now, if the thyroid produced a hormone to stimulate osteoblastic activity, well, the parathyroid hormone stimulates osteoclastic activity, which we remember back to the skeletal system. Osteoclastic activity is where the bones will break down, or excuse me, the cells will break down the bone, which then releases calcium into the bloodstream. And there is a condition where, there's issues with the thyroid where they don't properly function with this thing. So sometimes we'd have too much parathyroid activity where it's releasing too much calcium into the bloodstream and causes a lot of problems, or vice versa, where there's not enough calcium and causing lots of problems. So our adrenal glands, first, where are they and what are the different regions of the adrenal gland? Well, the word adrenal literally means on the renal or kidneys. So the adrenal glands sit on the top of the kidneys. Now, there's two regions of the adrenal gland. We have the adrenal medulla and the adrenal cortex, which is simply enough, just definitions. Cortex means the outer shell, and then medulla means the inner center, which we've seen these words before in the nervous system, as well as we've even seen medulla in the skeletal system, medullary cavity. So specifically, the hormones produced by the adrenal gland come from either side. So we have hormones that come from the adrenal cortex, and we have hormones that come from the adrenal medulla. So you can take a look here, and it shows you kind of like the breakdown. So the adrenal cortex produces the vast majority of them, which is aldosterone, cortisol, and androgens. So specifically looking at aldosterone and cortisol, those ones are kind of important. So aldosterone, very similar to the antidiuretic hormone, stimulates the retention of water. So again, that's going to help keep the blood pressure raised and keep the water in our system. And cortisol, now cortisol is probably the bigger thing that we talk about in the massage program. Cortisol has a bit of a bad rep in the massage world, I guess you could say, because over quantities of cortisol becomes a very stressor, a big stressor in the body. Now, cortisol's function does not necessarily mean to cause stress in the body. It does serve anti-inflammatory properties, and helps with, managing pain, managing, injuries and trauma, stuff like that. But there are instances where this this hormone, this cortisol, can be released in higher quantities and be sustained within the bloodstream, which then causes the body to be excessively stressed, which then massage therapy has been clinically shown to lower levels of blood cortisol in the body, which means we're clinically proven to relax the body per se. So the very center of the adrenal gland, the adrenal medulla, is where we find the quote unquote adrenal hormones, right? The ones we would often associate more specifically to the adrenal gland and adrenal function, which is epinephrine and norepinephrine. So those collectively we call our adrenal hormones. So now they've, of course, share various functions of, stress response, stress adaptation, but they also do other things in the body other than that. But in regards to, massage therapy, we talk about them, being kind of the, stressors of the body, during the fight or flight response. And again, massage can help to lower the levels of those in the body. The pancreas, also an endocrine gland, technically an endocrine organ, serving endocrinatic functions. The pancreas has specialized cells. We have the alpha cells and beta cells, which they are responsible for producing glucagon and insulin. So we often call these little cells too pancreatic islets or islets, and we often will call them islets of Langerhans, I guess, because that's the guy who found them. And so we have the alpha cells and beta cells. Alpha cells producing glucagon and beta cells producing the insulin. So as we mentioned before, the glucagon causes us to release and use blood sugar. Insulin drops blood sugar. So glucagon is going to release the blood sugar sugar into the blood. It's going to break down our surplus stores of sugar, usually in those fatty deposits we have, the adipose cells, and then insulin is going to cause us to take it out of the bloodstream. And then so basically we already talked about that, and this is actually the cycle of breaking it all down and using it, right? Which, like we said, glucagon releases sugar into the bloodstream for use, right? Especially for during exercise activities. Obviously when we're engaging ourselves, and then of course when we're at lower activities and we need to store all those energies, well, insulin will then reabsorb that into our body. The ovaries, what hormones do they produce? So they produce estrogen and progesterone as well as relaxin. So obviously the biggest example would be the estrogen, right? We all understand that as the female hormone. Of course, males do use estrogen as well, and females also use testosterone as well, just different quantities. So estrogen, right, just stimulates the ovaries basically, and this essentially is our reproductive lecture, which is what glands are in the reproductive system and what hormones are they producing. Relaxin is interesting. I skipped myself. Relaxin is actually interesting. It's produced during pregnancy and childbirth to help relax up the structures of the pelvis so that birthing can be a little bit easier. The primary hormone produced by the testicles, well, if you couldn't guess, testosterone, right? We know loosely enough what testosterone helps with. So our heart, so like we said, other organs can secrete various hormones, like our heart, our kidneys and all that, right, can produce hormones. The heart will produce atrionatriuretic hormone, which the atrial, for the atria of the heart, natriuretic, right, is going to help to decrease blood pressure, right? So like we said, that the heart and blood vessels can kind of monitor the blood pressure levels of our body. And so if we need to, or if the blood pressure is too high, we increase urine production to then lower our blood pressure, which our kidneys will also produce. Just going into pathologies, our kidneys will actually produce renin, which essentially does kind of the same thing. So our kidneys are also going to serve this similar functions of monitoring blood pressure and releasing excess waste. And that is the endocrine system, minus going into the different pathologies, which we already have that in another video. So let me just go ahead and zoom in on this. Now, what I didn't do is was to actually go in and write down. I would just probably just write down all the different organs and various other glands that produced hormones and then what they did. And then of course you can go in and clean this up a little bit, make it a little bit more elaborate. But to be honest, that's really the lecture right there. As a matter of fact, sometimes I usually draw draw a little something here. So we have hypothalamus. So from anterior, we had I'll draw like a little straw, and I'll draw infundibulum. And then over here, I draw like a little neuron. and say neurohypophysis over here. So that way, you know, you just had a little visual representation of how the nervous system and the endocrine system linked, or well, you know, the hypothalamus linked to that, which technically the relationship between these two glands, these two structures, is like the bridge between the nervous system and the endocrine system, basically. So kind of cool. Honestly, one of the cooler systems in the body, right? I mean, it's literally drugs. Who knew? But yeah, that's gonna do it for the endocrine system.